In this lesson, we're going to look at carboxylic acids, which is the last family of compounds that we're going to look at in detail. Again, we're going to look at 4 parts: structure, bonding, physical properties, chemical properties, and how can we prepare carboxylic acids. So we have learned that carboxylic acids contain this functional group, meaning members of the family of carboxylic acids, they actually have this feature. So when you see C double bond OOH, it tells you that that compound belongs to the carboxylic acid functional group, carboxylic acid homologous series. Okay, again, I'm going to give you the general formula, which is CN-1H2N-1COOH. In some textbooks, you may see a different general formula, or some teachers may teach a different general formula, which I will show later. The reason why I prefer this is it's more straightforward. Reason being, N usually represents number of carbon atoms. So for a carboxylic acid with 1 carbon atom, we call it methanoic acid. If you follow the general formula given, you will be able to arrive at this molecular formula. For carboxylic acid with 2 carbon atoms, it is called ethanoic acid. Should be able to get the following molecular formula. This is the acid that we are most familiar with. We have learned it under acids and bases, and this is our vinegar. For a carboxylic acid with 3 carbon atoms, we call it propanoic acid. So it has this C2H5COOH, and then next, an acid with 4 carbon atoms, we call it butanoic acid, and it has the following molecular formula. Now for the displayed formula and your condensed formula, I'm just going to illustrate using one example. So by now you should be more or less familiar with that. So I'm going to use propanoic acid as the example. So propanoic acid has the following functional group: COOH. Reminder to show the bond between O and H. Okay, propanoic acid contains 3 carbon atoms. There's already 1 in your COOH, so we need to add 2 more, and we are going to fill up the rest of the bonds with hydrogen. Now if I represent propanoic acid in condensed formula or in structural formula, then all I need to do is to collapse the hydrogen atoms around each carbon. So first carbon has 3 hydrogens, second one has 2 hydrogens, and then we write COOH. Okay, so this is your displayed formula, or your full structural formula, and the one below is your condensed formula, both of which you can actually derive the arrangement of atoms in the molecule. Now earlier I mentioned that there's another general formula that some teachers or some textbooks may teach. It is this CnH2n plus 1 COOH. Now this general formula works as well, alright, but your N must start from 0. Okay, meaning the first member of the carboxylic acid family, if you were to use this general formula, you must put in N equals to 0. Now why is that so? It's because there's already 1 carbon atom in your functional group. Okay, since there's already 1 carbon atom in your functional group, the first member will not have any additional carbon atoms. Alright, so if you use this formula, the second general formula, you have to remember that N starts from 0. Otherwise, I would recommend that you stick to this general formula, where you can use the definition of N as the number of carbon atoms in the molecule. Next, we will look at the physical properties of carboxylic acids. Good news is that it's exactly the same as alcohols. Now, why is that so? Because if we look at the functional group of a carboxylic acid, it also contains your OH group. Alright, what does it mean? It means that acids are capable of forming hydrogen bonds with themselves, with water. So therefore, even though they have simple molecular structures, their boiling points are not that low. Alright, even for carboxylic acids. So for carboxylic acids, they are no longer volatile liquids, they are simply liquids. The first few members of the carboxylic acid family, they are liquids. Okay, same boiling point, melting point increases as the size of acid increases. And then since acids can form hydrogen bonds with water, they are actually very soluble in water. Alright, that's how you can mix vinegar with your soup. Okay, so again, solubility will decrease as your size of acid increase. So you can remember that the physical properties of carboxylic acids is almost exactly the same as alcohols. The physical properties of alkenes are almost exactly the same as alkanes. Now, before we go into the reactions of carboxylic acids, I want to go through the last part, which is preparation first. But this is nothing new. Alright, how do we get carboxylic acids? If you think of the reactions that we have learned so far, which reaction produces an acid as the product? And the answer would be the oxidation of alcohols. Okay, so when you oxidize ethanol, there are two ways that we can use we can use your acidified potassium manganate 7. Okay, and then you heat it or you warm it. So what will happen is that your ethanol will be oxidized to acid and water. The second way that we can do it is by air, oxygen in air, but you need bacteria to act as a catalyst. So in this case, the same reaction will happen. Your ethanol will react with oxygen in air to form your acid. Okay, so the method for preparing carboxylic acids will be to oxidize an alcohol. Okay, and before I go on, another reminder, when you oxidize an alcohol, you get the corresponding acid, meaning the number of carbon atoms don't change. So if I oxidize, for example, pentanol, what acid will I get? I will get pentanoic acid. So there's no change in the number of carbon atoms from oxidation. Now we'll look at the chemical properties of carboxylic acids, or the type of reactions that they can undergo. Now, good news is we are looking at the reactions that carboxylic acids can undergo. Alright, since we call it an acid, essentially the reactions that we have learned where acid can whatever the acid can react with, your carboxylic acid can react in the same reaction. Alright, so for example, if we look at ethanoic acid, okay, we have learned that it is a weak acid and it can dissolve in water, it can dissociate, or it can ionize to form your hydrogen ions. Okay, so it's because of these hydrogen ions that your carboxylic acids are acidic. The other thing is, we have learned that your ethanoic acid or organic acids in general, they are weak acids, meaning they only ionize partially. So most of it will remain in the molecular form. Only a small part of it will undergo ionization to give you H+. But nevertheless, it behaves like an acid. It will undergo any reaction that an acid can undergo. So we have learned that acids can react with three things. Acids can react with metals or reactive metals, not all metals. Acids can react with metal carbonates, and acids can react with, lastly, your base or alkali. Alright, so next thing that we need to recall is what happens when an acid reacts with reactive metals. We get a salt plus hydrogen gas. When it reacts with a metal carbonate, we get a salt, carbon dioxide, and water. And then when it reacts with a base or alkali, we get a salt and water. Alright, in the next slide, we're going to look at how to write the chemical equations for each of them, which is slightly trickier than the usual acids that we deal with. So now we'll try to write the chemical equations for the reaction of ethanoic acid with a metal carbonate, and with an alkali. Right, as mentioned, it's going to be slightly trickier than the acids that we are familiar with. So how do we overcome that is to recognize this, that ethanoic acid, when it ionizes in water, it forms this particular ion, this particular anion. Okay, this anion is called your ethanoate ion. Okay, so the salt that you get from reacting ethanoic acid with a metal, with a carbonate, with an alkali is obtained. The salt that we get is obtained from ethanoate combining with a metal cation. Alright, we'll see in a while. So ethanoic acid CH3COOH reacting with magnesium. We have learned it will produce hydrogen gas. Now what is the salt that is formed? Now magnesium metal, when it reacts, it will form magnesium ion, which is Mg2+. Okay, so when Mg2+ combines with ethanoate ion, so how do we combine it? We have learned in the topic of writing chemical formula that one way is to write down the number on the charge and do a cross multiplication. Right, that would give us Mg CH3COO2. Okay, now there's something new that I want to teach here, which is when you're writing the salt that is formed from an organic acid. Okay, when you're writing the formula of a salt that's formed from an organic acid, the convention of writing the cation followed by anion, it is salt. Alright, so whenever we write the salt, the formula of the salt that is formed from an organic acid, we write the anion first, meaning CH3COO2 followed by Mg. Okay, but however, in the context of O levels, even if you don't write that, you will still get it correct. Okay, so even if you write cation first followed by anion, you'll still get it correct. Now why is the convention switched? Is this: if you think of the ionic compound that's formed from your metal and your ethanoate ion, where is the metal ion connected to? Alright, is it connected to your C or is it connected to your O? The answer is, this is how the ethanoate ion looks like. So there's a minus charge. So your Mg2+ is actually connected to the O. It's actually next to the O rather than the C. So that is why for salts that are formed from organic acids, we will put the metal just next to the oxygen in the formula. Okay, but again, as I've mentioned in O levels, even if you write it as the cation followed by anion is perfectly fine. But the convention for organic salts formed from organic acids is that we write the anion followed by the cation. So the equation is not yet balanced, so I'm going to balance it now. We need 2 ethanoic acid, and then the equation is balanced. Now next, ethanoic acid reacting with sodium carbonate. Okay, we will get salt, carbon dioxide gas, and water. Okay, so again the salt is formed by combining the metal ion with ethanoate. So in this case, it's just CH3COO and 8 because Na is Na plus and CH3COO minus. Okay, so now let's try to balance the equation. We need 2 over here because there are 2 sodium, and then after that we need 2 over here, and then the reaction is balanced. Okay, the last example, ethanoic acid reacting with sodium hydroxide. Ethanoic acid so acid plus alkali gives you salt and water. The salt again is obtained by combining your ethanoate ion with your metal ion followed by water. Okay, so this is how we write the equations for the reaction of ethanoic acid or any organic acid with a metal, with a carbonate, with an alkali. Now there's one more reaction that carboxylic acids can undergo, and it is the most important reaction for carboxylic acids. So carboxylic acids can also react with alcohols. This reaction will require again a specific set of reagents and conditions. We need concentrated sulfuric acid as a catalyst. Okay, and then we need to heat the reaction mixture. So what happens when you mix a carboxylic acid and an alcohol in the presence of concentrated sulfuric acid and heat? This is what is going to happen. Now, to better show the product of the reaction, it is a good practice to make the functional group of your acid and your alcohol face each other. Alright, meaning I'm going to draw it out again. So this is my acid, okay, and I'm going to make it such that the functional group of your acid and alcohol faces each other. Okay, so what happens when acid meets alcohol? Acid will lose its OH group. Alright, your alcohol will lose the hydrogen. Okay, so when OH is removed from acid and H is removed from alcohol and they combine together, what do you think can be formed? Yes, it will be your water. Alright, so the reaction of a carboxylic acid and an alcohol will form water. Now how about the so now they are gone. Now what is the other thing that can form? The other thing, to get the product, we simply need to connect. Okay, we simply need to connect the carbon to your oxygen. Okay, so it forms a CO single bond. What do I mean by that? So I will draw out the structure of the acid, okay, minus the OH group. I will draw out the structure of your alcohol minus the H, and then the product that is formed is by connecting the C to the O. Alright, so the bond that is formed is a CO single bond. Alright, so these are the products of the reaction. Now if you look at the new organic compound that is formed, it also has a special feature in this molecule, and the special feature is this. It's your COO bond. Okay, indeed this special feature is a functional group on its own. Alright, what functional group? We call it an ester functional group. Okay, and all compounds that has this feature, this ester functional group, they fall in the family of compounds or the homologous series of esters. Okay, we're not going to learn esters in very much detail for O levels, but there is this family of compounds called esters. So the next thing that we need to know is that the reaction of a carboxylic acid with an alcohol is actually a reversible reaction. We have learned reversible reactions under the topic of ammonia, right? It means that the reaction can go in the forward direction, it can go in the reverse direction. Now the reaction in the forward reaction is known as esterification. Okay, esterification, meaning the formation of an ester. The reaction for the backward reaction, the name for the backward reaction is called hydrolysis. Okay, meaning after an ester is formed, it can react with water, alright, and undergo hydrolysis to form back your acid and your alcohol. Right, we have learned that when a carboxylic acid reacts with an alcohol, it produces a product that has a special feature, and the special feature is a COO function group. Alright, so this group we call it a functional group, and compounds with this functional group we call them esters. Now the thing to remember about esters is that they are sweet smelling. Right, this is the most important characteristics that is associated with esters. The next thing that we need to learn about esters is that how to name an ester. The name of an ester has two parts. Okay, since it is formed from an alcohol and an acid, so we will name it after the alcohol and the acid. In the name of an ester, we name the alcohol followed by the acid. Okay, now for example, if the ester is formed from the reaction of ethanol and propanoic acid. Okay, how do we get the name of the ester? We replace the suffix of the alcohol with YL. We replace the suffix of your acid with OH. Okay, meaning the ester that is formed from ethanol and propanoic acid is given the name ethyl propanoate. Okay, take note that there is a space, there is a blank between ethyl and propanoate. Alright, this blank is not there when we are writing the name of a branch alkane, alright, under isomers. That is why during that time I highlighted that there is no space when we are writing a branch, because a space in the naming of organic compounds, it carries a meaning. It tells you that it is an ester. Okay, so in the name of an ester, between the alcohol and the acid, there is a space. Now let's practice. Okay, so we have a few more examples. We have the ester that is formed from methanol and methanoic acid is, we replace the suffix of your alcohol with YL, we replace the suffix of your acid with OH. So the answer, the name for the ester is methyl methanoate. Again, take note that there's a space between methyl and methanoate. Very quickly, when we react an ethanol with butanoic acid, we will get ethyl butanoate. And next, given the name of an ester, we are supposed to predict the carboxylic acid that's used. Remember, the acid comes in the later part of the name. Alright, so we need to work backwards. What acid can give you ethanoate? Alright, and the answer is your ethanoic acid. Now let's practice drawing out the structure of esters given your alcohol and your acid. So draw the displayed formula of the ester formed from butanol and propanoic acid. First, we need to draw out the structures of both the alcohol and the acid. Okay. Secondly, as I've mentioned, it's easier to get a structure of the ester when you make the functional group of your alcohol and acid face each other. Alright, and lastly, the thing to take note over here is displayed formula. Alright, meaning every bond must be shown. Now let's draw the structures of propanoic acid and butanol. It is a personal preference to draw out the structure of your acid first, followed by your alcohol. Okay, so propanoic acid contains 3 carbon atoms. It contains the functional group COOH, and then we fill up the rest of the carbon atoms with hydrogen atoms. Now I'm going to draw butanol, but I'm going to make the hydroxyl functional group face your acid functional group. So OH, and then butanol means that there are 4 carbon atoms, and we're going to populate the carbon atoms with hydrogens. Now, in order to draw the structure of the ester, we need to remember, very importantly, we remove the OH from the acid, we remove the H from your alcohol. Okay, so we remove them. Your H and your OH will combine to form water. So you have water, and then your ester that is formed, we can simply get the structure of the ester by forming a bond, a CO single bond from your acid group to your alcohol group. So the displayed formula of the ester form is as follows. Okay, so this is already the answer. Okay, but try to draw the CO, make the CO bond shorter. This one looks highly weird. Okay, but essentially this is the structure. Okay, very importantly, please take note that when an ester is formed, a CO bond is the CO single bond is the one that's linking your acid and your alcohol together. Now, why is that important? Because when it undergoes the backward reaction, this is the bond that is broken as well. Alright, so you need to look out for the CO single bond. Now we practice the opposite. We are given the structure of an ester. We need to draw the acid and the alcohol that forms the ester. Essentially, we are asking you to subject the ester to hydrolysis to get back your acid and your alcohol. Now the key to solving such a question again is to find the bond that was formed between your acid and your alcohol when it forms an ester. And the bond that's formed is your CO single bond. Alright, so look for your CO single bond in the ester. Alright, if you can't, just locate the ester functional group first, and then after that find the CO single bond. This is the CO single bond, and this is the CO single and this is the CO single bond. Okay, after locating the CO single bond, break that bond and separate the two parts. So after breaking the CO single bond, I will get something like this. And alright, so how do I get back my alcohol and acid? I need to add back the H to the O, and I need to add a OH to my carbon containing the CO double bond. Alright, so this is how you can get the acid and the alcohol from the structure of the ester. Alright, let's try again. After breaking the CO single bond and then separating the two fragments, I will get something like this. Alright, so in order to get back the acid and the alcohol, I need to add back the H to my O, and I need to add a OH to my C double bond O. Okay, one last practice. In this practice, we look at an ester, but this time the displayed formula is not given to you, but rather it is given in some form of a condensed formula. So in order to solve this question, we need to be able to interpret this condensed formula. And in the condensed formula of an ester, this CO2, or sometimes it can be written as this COO. So this COO represents your ester functional group. Okay, and whatever that comes behind it, I wouldn't say behind, sorry, in front of the COO, this part is from your acid, and this part is from your alcohol. Alright, so essentially this condensed formula looks, if I were to draw out the structure, it actually looks something like this: COO C2H5. So the question is asking which acid will combine with ethanol to give the ester. So to get back your acid and your alcohol, remember to locate your CO single bond, and then you break it into the two fragments, and then you add back your OH and your H. Okay, so it's already given in the question. The alcohol is your ethanol, and now let's look at your acid. Your acid has 3 carbon atoms, okay, 2 plus 1, so it's your propanoic acid. Lastly, we need to know some uses of esters. Esters is easy for you to recall if you can associate esters as sweet smelling. So it's often used in perfumes, in soaps, and if you look at certain artificial flavoring, like the flavoring of pandan, it's actually associated with a particular type of ester.